Let's do a maximum warp race between all the major series Star Trek ships. I realized that I didn't really have a good understanding of just how fast each ship was going. So the Enterprise D goes warp 9.6 and the Voyager goes warp 9.975. And I guess the Voyager is faster, but how much faster? It's really hard to picture this stuff, so I put together some comparisons. We'll be comparing the speed of light, which is warp 1. Next comes the NX-01 Enterprise, which has a maximum warp speed of 5.2, which translates roughly to 140 times the speed of light. Then we have the 1701 Enterprise at warp 8, 512 times the speed of light. Skipping ahead to the next generation, the Enterprise D. Now, TNG uses a new warp speed scale. At this scale, its maximum warp speed of 9.6 translates to 1,909 times the speed of light. Deep Space Nine's Defiant has a Class 7 warp drive, which is rated for warp 9.5, exceptionally powerful for a ship its size, but slightly slower than the Enterprise D, clocking in at 1,841 times the speed of light. The Voyager represents a significant technological leap in warp speeds. Its Class 9 warp drive propels it to warp 9.975, which is 4,354 times the speed of light. And finally, let's look at the Enterprise E. There's no solid specs on its maximum warp speed. Some say warp 9.7, some say warp 9.985, and some say warp 9.995. Warp 9.7 felt a little slow to me, and 9.995 seems a little fast, so let's go with 9.985. Now, I know there are plenty of examples of these ships going considerably faster than their supposed maximum warp speeds, but I'm not going to deal with anomalies or alien-enhanced engines or how fast the ship can theoretically go but with significant damage or danger to the ship. I'm going for its maximum warp speed as it would appear in the manual for each ship. So let's come up with a test here. I've chosen to race these ships from Earth's orbit to the edge of interstellar space. That's roughly 123 astronomical units. 123 times the distance between Earth and the Sun. That's some 11.4 billion miles or 18.3 billion kilometers. So the first line is Earth's orbit, and the last line is the beginning of interstellar space. And here are the orbits of the gas giants in our solar system for reference. The ships won't be to scale, of course, but their speeds will play out in real time. Ready?
Engage.
The Enterprise E and Voyager tear through the course, leaving all the other ships in the dust, but the Enterprise D and the Defiant are still going pretty dang fast compared to the 1701 and the NX-01. Now, when I first ran this test, I was thinking, man, these ships aren't really that fast, are they? But looking at light there, it's barely 5 million miles into the journey. But remember, that's also light speed. Light is crazy fast, and even the NX-01, which looks like it's barely moving, is going over 100 times as fast. Still, the NX-01 and the 1701 are taking a while. They would take roughly 7 minutes and 2 minutes respectively to finish. Light would take 17 hours to make this journey. Now, I don't think we got a really good look at the NX-01 and the 1701, so I set up a test just for them. We're going to race from Earth to Jupiter with light, the NX-01, the NCC 1701, and, well, we'll throw in the Enterprise D for fun.
Engage.
The NX still feels a little slow here, just goes to show what 100 years of warp drive development can do. And there's our little beam of light still struggling to keep up. It would take light over 40 minutes to make this journey.